second quarter for week 3 to 4, lesson functions and relations. The standard form of the equation of the line is ax plus by is equal to c. To graph the line, you need to find the ordered pair xy as defined as x comma y or xy that will satisfy the given equation. Hence, there is a relation that exists between these two elements. That one may be depending to the other. X is the independent variable here and y is the dependent variable here. The first element of the ordered pair is the x, the variable x. This is called the abscissa. And the second element, which is the y, is called the ordinate. The set of abscissa is the domain. So, there is a set of abscissa that is called domain. And the set of the ordinate is called range. Thus, a relation is a set of ordered pairs. A relation between the domain and the range can be presented in different ways. So, a relation between the domain and the range can be represented in different ways. So we're going to show different ways how domain is related to the range, or the x variable coordinate to the y variable or y coordinate. So the first one is the arrow or the mapping diagram. This consists of two parallel lines, parallel columns. The first column represents the domain of the function. So it means that the first column of the arrow or mapping diagram should be always for the variable x, and the other column its range or for the y. So let's have an example. Show the arrow or mapping diagram of the relation of a children to their mother. As we all know, blood relations are highly valued by Filipinos. Children are taught to love, respect, and care for their parents, grandparents, and other relatives. So, this is our example. Suppose Mark, Jose, Ella, Ellie, Mike, Ray, and Sweet are the children. So we name the first column as children, name it, and this is for the variable x. You can box this, or you can circle it, or you leave it this way, it's okay. Then we have Maria, Marla, Marian, which are the mother. And this is for the variable y. So in this case, let me draw a box for this. And then this one. Okay, how can we show the arrow diagram or mapping diagram? We will pair the children to their mother. So Maria has a children of Mark. So we draw it an arrow here. Then Jose. Then we have Ella for Marla. Then Ellie for Marla as well. And then for the remaining 3 children, for Marian. So we connect it with the arrow diagram, with the arrow, and this is called arrow diagram or mapping diagram. Okay, so this is the arrow or mapping diagram of the relation of the children to their mother. So we can see that there are 2 elements or 2 x for Maria. So when we write this as an ordered pair, you can write this as, so we write, we use the braces here. So we use the braces, we identify the domain. So the domain should be a set. So set is written as open braces, not parentheses, not bracket, but we use braces. So we have for the domain, the domain is intended for the X or the first column. So that will be Mark, comma, Jose, comma, Ella, comma, Ellie, Mike, Ray, and Sweet. So this will be close with the braces also. So this will be close with the braces. So these are the set. So remember that when we talk about set, it should be with the open braces, then enclosed with the braces as well. And then for the range, this is the mother or the second column. So it's also a set, so you have to draw, never forget the braces. So we have Maria, we have Marla, and we have Marian. So this has a relationship of many to one. And many to one correspondence, many to one correspondence is function. So we call this function. Again, why it become many? Because Mark Jose map to Maria, Ella Ellie map to Marla, Mike Ray Sweet map to Marian. So this is many that is mapped to only one. So that is called many to one correspondent, and this shows a function. So let's interchange what will happen if that change or affect the mapping or the arrow diagram. So show the arrow or mapping diagram of the relation of a mother to their children. So I just interchange it just to show that it would affect the process. So Maria, Marla, and Marian will be the mother, and that will be the first column that is intended for the X or for the domain. And Mark, as we name it as children, and that is called for the range. So here we can draw a circle here, and they're here also. Okay, so we have the mother as Maria, Marla, and Marian, and the children is Mark, Jose, Ella, Ellie, Mike, Ray, and Sweet. So we're going to draw an arrow diagram. So Maria to Mark, Maria to Jose, then Marla to Ella, Marla to Ellie, then we have Marian to Mike, Marian to Ray, and Marian to Sweet. So at this example, our domain or the set of the domain will be Maria, Marla, Marian. So open braces, then close braces. Then for the range, so this is the X and this is the Y. And for the range for the second, that will be set of children, which is Mark, Jose, Ella, Ellie, Mike, Ray, Sweet. So compare to the previous one. So our relationship here will be one to many, because the mother is paired to children. So this will have one to many correspondence. And if this is one to many, then this is relation. So again, why it's one? Because the mother is paired with their children, and mother is only one, and then they are paired to 2 to 3 children, which is are many, considered many. So one to many correspondence and the relations, and this is a relation. So this is the first ways to show the relation of the domain and the range, the arrow diagram or the mapping diagram. So let's proceed with the ordered pair. So with the ordered pair, this is the set of X and Y pair. The X coordinate is always the first element or the domain, while the Y coordinate is the second element or the range. So let's have an example. Set of numbers are set of examples 1, 2, 3, 4, 5. So these are our set of the domain. So let's have 3 conditions that we're going to solve it. So set A will be the range is twice the domain. Twice the domain. So this is a set now. So set of, so we're talking about the ordered pair. And for the ordered pair, it should be x, y. So our x is 1. We have 1 as the x, so 1. Our condition is twice the domain. So twice, it means we have to multiply 2 for each domain to get the range. So 1 times 2 is 2. So that is the first ordered pair. Okay. For the second ordered pair is 2. 2 times 2 is 4. That is twice the domain. So the range is twice the domain. So this is can be 2 times x. So y is equal to 2 times x for the equation. Okay, now let's have 3. So your x is 3, you substitute it with the x, so 2 times 3, that will be 6. And then we have 4. Our x is 4, we substitute it, 2 times 4 is 8. And then for the last, we have 5 as the value of the x, we substitute it here, so 2 times 5, that is 10. So this is the set of ordered pair given the domain as 1, 2, 3, 4, 5. So here, what will be the range? So our range will be equal to the set of 2, 4, 6, 8, 10. That's it. Okay, let's go with the second condition. Range is 1 more than the domain. 1 more than the domain. So when we represent this as an equation, it means 1 more than the domain. So x plus 1. So plus 1 means more than 1. Okay, so set B will be, so our first x coordinate will be 1. So we substitute it here. 1 plus 1, that will be 2. Okay, for the second one, 2. 2 plus 1, 3. Then we have 3. 3 plus 1, that will be 4. Then we have 4. 4 plus 1, that will be 5. And then we have 5. 5 is the x plus 1, that will be 6. So these are the set B where range is 1 more than the domain. So our range here will be set of 2, 3, 4, 5, 6. Then the last condition, range is greater than the domain. So here we can give any. This is huge, so you may decide whichever you want, as long as it should be greater than the domain. So that will be y is greater than the domain. Greater than the domain. So it's inequality. So set C. So if I have 1, I can write 2 because that is greater than. So 2 So 2 can have 3. So I can have also again 1 and I can make it 3. I can have also 2 and make it 7 because there are so many answers that you can give. So 1, you can have 1, 2, 1, 3, 1, 4, 1, 5, so many. So we just write ellipses. And then we have 5, 6. So these are example. So in our given, our range will be more than the domain. So let's go back with the set A. So in set A, as we can see, 1 is paired to 2, 2 is paired to 4, 3 is paired to 6, 4 is paired to 8, and 5 is paired to 10. So this is 1-to-1 correspondence. For set B, 1 is paired to 2, 2 is paired to 3, 3 is paired to 4, 4 is paired to 5, and 5 is paired to 6. So there's also 1-to-1 correspondence. So A and B are function because they show 1-to-1 correspondence. Whereas C, 1 is paired to 2 and 1 is paired to 3. Then we have 2, 3, and then we have 2, 7, and so on. So here we can see that many-to-many correspondence. So here we have 1-to-1 correspondence. So this is function. And here is many-to-many correspondence. And this is an example of a relation only. Okay, so these are the two ways to represent the relation between the domain and the range. That's